All right, everyone, welcome to our MCAT webinar. Our topic today is going to be on how to crush the MCAT Chem, Phys, and CARS sections. The reason why we're going over these two sections in particular in the MCAT is because these are the sections that students have the most trouble with. So you're going to find that the tips and strategies we're going to provide you today is really going to be able to help you with these two sections. So to start off, we're going to start first with quick introductions. So as you can see, my name is Ken. I am the MCAT Program Director for Med School Coach. So that means I oversee our entire MCAT program, everything that we do for helping students prepare for the MCAT.
All right, and hello everyone. My name is Kathryn, and I'm one of the tutors with Med School Coach. I'm also a master tutor with the company, and I really enjoy helping students get to their goal score on test day. And I like talking to you all on these webinars, so it's great to be here.
All right, fantastic. So on this slide, we have the plans for today. We're going to start first with actually a quick introduction as to the format of the MCAT exam. We know that we have all types of students as well as some parents in the audience today. And some of you are familiar with the MCAT, some of you are less familiar. So we'll just start first by going over the exam format so everyone's on the same page. We're then going to discuss a little bit on why these two sections of the exam, the Chem, Phys, and the CARS sections, are particularly difficult. And from there, we're going to talk about tips and tricks for the Chem, Phys, and CARS sections. And as part of that discussion, we're actually going to go over a sample passage for the Chem, Phys section. So you can see hands-on some of these strategies that we apply and we teach our students all the time. And finally, the last thing we're going to do is we're going to have an open Q&A where we're going to answer questions from all of you regarding anything related to the MCAT exam. Okay, so to start off, the MCAT exam has 4 sections. The first section is called the Chem Phys section. It's 95 minutes, and the full name of this section is the Chemical and Physical Foundations of Biological Systems. It is an extremely long name, and that is the case for all 4 sections of the exam. The second section is the CARS section. This is the Critical Analysis and Reasoning Skills section. It's 90 minutes long. The third section is the Biochem section, or the Biological and Biochemical Foundations of Living Systems. And the last section is the Psychological, Social, and Biological Foundations of Behavior. You'll notice that each of these sections are about an hour and a half long, and this is just the testing time, right? So on your actual exam, you're also going to have breaks in between and some tutorials that you might want to go through if you're not familiar with the online tools of the exam. So if you put together all those breaks, you're going to find that your testing experience on test day is going to be about 7.5 hours long. This is a really long exam, and most pre-medical students have never taken an exam of this duration. So that's what makes the exam difficult. Number 2, the scoring system. The MCAT has a score for each section of the exam between 118 to 132, 118 being the lowest score and 132 being the highest score. Right in the middle of that range is 125. That is the average score on each section. And this is actually really convenient for medical schools because it allows the medical school admissions committees to be able to quickly identify if a student is above average, meaning that their MCAT scores are in the 500s, or if the student is below average because their MCAT score is in the 400s. And that's simply because if a student gets an average score on all 4 sections of the exam, they'll be left with a perfect 500. Okay. Now, you'll also notice here that the MCAT follows, for the most part, a normal distribution. So that means most students are going to be right around that middle, that average score of 500, and very few students are going to be scoring very high or very low on the MCAT. Number 3, question types. So the MCAT is a standardized exam, and as a standardized exam, it actually has only multiple choice questions. And this is pretty interesting because if you think about a lot of the courses that you take to prepare for the MCAT, such as general chemistry, organic chemistry, and physics, you're probably not used to taking multiple choice tests for these courses. And that's because for these exams, you usually have a lot of free response questions. Questions asking, for example, how to do calculations, stoichiometry calculations for chemistry, forces calculations for physics, or even drawing out molecules and arrow pushing diagrams for organic chemistry. You won't be required to do any of that for the MCAT, but that doesn't make the MCAT any easier of an exam. If anything, as a multiple choice test, the MCAT is actually quite difficult for students because they're not used to being tested these same concepts in a multiple choice format. Some other things I also want to mention that every question on the MCAT is worth the same amount of points, so it does not benefit you to spend more time on the harder questions and not get to the easy questions, right? If anything, your goal should be to complete all the easy questions and save the harder questions for later. There's also no guessing penalty, so that means when you're taking the MCAT, you should never leave any question blank. And finally, there's something I want to emphasize here, that the MCAT has both passage-based questions and freestanding questions. The passage-based questions is really what makes the MCAT a particularly difficult exam. If you compare the MCAT with the other pre-health exams, OAT for optometry school, DAT for dental school, and the PCAT for pharmacy school, one of the reasons why the MCAT is harder than all of those exams is because of these passage-based questions. If you look at the natural science sections on those other pre-health exams, they're all freestanding questions. So it's simply, do you know the science content or not? On the MCAT, you do have some freestanding questions in that format. However, the passage-based questions will be associated with passages. These passages will introduce new information and new situations that you've never learned about before. And in order to answer the questions, you have to apply your knowledge of science to the passage information to figure it out. So you can really think of the MCAT as an applications test. And that's something that a lot of students finds very difficult. Okay. And finally, the last thing you should recognize is that the MCAT is only offered in the months of January as well as March through September. That's most of the year, but notably it's not offered in February or October, November, December. You just want to keep this in mind as you think about when you want to take the MCAT exam. And of course, there are multiple test dates available for each month. Last point I want to make is make sure that you register early so that you can get your desired test date and testing center. You might have heard of students that have had to book test dates that they didn't want, right? They were studying for a January test date, but January test dates filled up, so they ended up having to sign up for a March test date. Or other students where, because they signed up late, they couldn't even get a testing center in their city, so they might have had to travel 2 hours to their test date or testing center, which you definitely don't want on test day, or some of them have even had to fly to other states to take the MCAT. So when you're thinking about taking the MCAT, make sure you register early so you get the test date and testing center that you want. Okay, so that gives us a great overview of the MCAT. Next thing we're going to look at is the Chem Phys section and the CARS section in more detail. So the first thing you're going to see here is the question, why is the MCAT Chem Phys section so difficult, right? And we know this because we hear this from students all the time, right? That they are doing well on many sections of the exam, but the Chem Phys section, they're always struggling with. There's several key reasons why the Chem Phys section is difficult for a lot of students. The first is that it integrates a broad range of subjects. So by this, I mean, if you think about the name Chem Phys, you certainly have chemistry and physics. But if you actually look at the distribution of subjects on this section, you're going to see that it has 5 different subjects, right? The Chem Phys section is 30% general chemistry, 25% biochemistry, 25% physics, 15% organic chemistry, and 5% biology. If you think about the college courses that you took, for example, general chemistry, and think, how much of that general chemistry knowledge did you need for the organic chemistry you took the next semester? For most students, it's not much, right? So what happens in college is usually students will take a class and after that semester, they'll forget everything they learned about that class. That's not something you want to do for the MCAT because you can see the Chem Phys section is going to combine all of these subjects together. And it's not just you're going to have this section with questions covering all of these subjects. You're going to have passages that are going to have questions on multiple subjects. So for example, you can have one passage in the Chem Phys section with maybe a couple of biochemistry questions, an organic chemistry question, and possibly a physics question thrown in there as well. So that's something students aren't used to, but it doesn't mean that this isn't something that you can't prepare for. One way to help you with this is just as you're reviewing the science content for the MCAT, don't just review one subject at a time, as in you don't want to just read your physics book for the first 2 weeks and then your general chemistry book for the next 2 weeks. You want to constantly cycle through the different subjects so you're thinking about all the subjects at the same time. Number 2, the luck factor. Now, this is not something that students want to hear, that there's a luck factor to the MCAT, but in practice, there is, right? And one way to explain this is consider, for example, physics on the Chem Phys section. For the MCAT, it covers 2 semesters of physics. For most college level institutions, the first semester physics is going to be Newtonian mechanics. So looking at kinematics, forces, work and energy. The second semester is on electricity and magnetism. There's a lot of concepts covered in these 2 semesters of physics. On the Chem Phys section, it's 25% of the section. There are 59 questions on the science sections of the exam. So that means you're looking at a total of 12 to 13 physics questions on your exam. And there's no way that 12 to 13 questions can cover all of the physics topics in 2 semesters worth of physics. So because of that, the specific physics topics that you see in your exam, that's where the luck comes in, right? So for some students, they might be like, oh, I'm really good at physics 1. That forces, work energy, kinetic energy, potential energy, I understand that really well. But the second semester concepts, lenses and mirrors, I never really get that, right? So if you've never really understood lenses and mirrors, if on test day you don't get a passage on lenses and mirrors, then you're going to be really happy because you're going to do well. But if you get unlucky and you get an entire passage on lenses and mirrors, then that can really throw you off. Right, so there is a luck factor that all students have their own strengths and weaknesses. So it's a matter of, on test day, do you see questions on your strengths, your weaknesses, or sort of what is the ratio of the 2 on test day? And of course, the ideal way to deal with this is to be thorough with your content review and make sure that you don't have any weaknesses and that everything is a strength for you. Okay. Number 3, the MCAT Chem Phys section is also difficult because it requires a complex set of reasoning skills. Remember what I said earlier, it's not simply knowing the science content because the MCAT isn't just freestanding questions. You have a lot of passage-based questions, and these passage-based questions will require reasoning skills. The specific skills are knowledge of science concepts and principles, scientific reasoning and problem solving, reasoning about the design and execution of research, and data-based and statistical reasoning. If you look at some of these topics, you'll see that they're not specifically just asking you, do you know the science content? But sometimes they're asking you to be able to think about experimental design. How was the experiment designed and how could it be altered? Or looking at data, what conclusions can you draw from the data? What conclusions can you not draw from the data? This is something that a lot of students don't learn in college, right? Often you're learning a lot of the science concepts, but this is where a lot more of the application takes place, right? It's not simply, do you understand the science concepts, but how are these science concepts applied in real life? And what you'll see on the exam is that a lot of these passages are adapted from scientific journal articles. So for those of you with more research experience, you'll find that your ability to answer these questions is probably a bit higher because your research is helping you with this. All right, and finally, this is another great reason why the Chem Phys section is difficult, math. Right, the Chem Phys section has more math than any other section of the MCAT. So math takes time. So for students where math is a weakness of yours, then of course it's going to take you more time So that's why it's very common for students to be running out of time or running low on time for the Chem Phys section. And related to this, of course, is the memorization aspect. Sometimes the MCAT is nice and it'll give you the equations and constants that you're supposed to have memorized for the exam, they'll sometimes give you the equations and constants you need to answer the questions, but sometimes you're going to be expected to have those equations and constants memorized. So all of these reasons can make the Chem Phys section difficult. All right, same thing, but now for the CARS section. CARS stands for Critical Analysis and Reasoning Skills. First reason why it's difficult, no content knowledge required. This can actually be surprising because if you think about it, how great would it be to be tested on an exam where you're not expected to know any science content, right? At first that sounds great, but of course, those of you who have done any sort of verbal reasoning or reading sections on other standardized exams know that this isn't so easy, right? It's true that there isn't any prerequisite science knowledge you're supposed to know, but this section can still be challenging because then it's testing your ability to read and interpret the passages and think critically about what arguments is the author trying to make, as well as what information, if introduced, would affect the author's arguments. So this is not easy for students to do, so that's why the CARS section can be difficult. Number two, these skills can be difficult to obtain, right? So a mistake that a lot of students make is they just think, oh, well, since the CARS section doesn't test any content knowledge, there's nothing I can do to study for this section. So they're just like, oh, I just won't do anything. And, my score will just be what it is. That's definitely not the case. CARS skills can be learned. And it's something that you need to put time and effort into learning. If it's not something that you're used to doing before, then of course it's something that you have to put in time and effort in order to learn. And one of the best ways in order to learn these skills is by doing practice questions and reviewing the questions and learning from your mistakes. And I'm not going to talk too much about this now because later Kathryn's going to discuss this in more detail, but it's not easy to do, but it can be done. Number three, the passages cover a variety of disciplines on humanities as well as social studies topics. If you take a look here on the right, we have all of the different topics that show up on the MCAT exam. This is where we see another common problem with students, especially if these are students that are interested in certain topics but aren't interested in other topics. These are students that read a passage on philosophy and they're just thinking, oh, this is so boring, right? Like, I don't want to read this. I don't understand what's going on, right? If you have that mindset, that's definitely going to hurt you, right? It's true that if you look at a lot of these topics, you might not have personal interest in these topics, which is why you're probably trying to become a physician and studying a completely different topic. But this is the CARS section. And if you're just thinking about how bored you are the whole time reading the passage, then you're definitely not going to be able to extract the main idea of the passage, which is super important for doing well in the CARS section. So one thing you should always try to do is when you're reading a CARS passage, try to be as engaged as possible. Remember, anyone writing these CARS passages, these texts, they wrote them for a desired audience. So try to put yourself in the position of an audience member that is extremely excited and interested in reading these CARS passages. And in doing so, you're going to be much better at being able to understand the passage and get those questions right. Okay. The last reason why the MCAT CARS section is tough is because of the time pressure. This we hear all the time. Just as we mentioned earlier that students often run out of time on the Chem Phys section, the same is true for the CARS section. There's a lot of time pressure on the CARS section. So for a lot of students, they often run into this issue where they're not able to complete all of the passages or they have to rush to complete the passages. And because they're rushing, it hurts their accuracy, right? So pacing is another strategy that students need to learn for the exam. And again, pacing is something that can be learned. It's not just you're a slow test taker, therefore you're never able to get through all the passages and questions. It is something that you can learn. It's not easy, but again, it can be done. Okay, so now that we've discussed why these two sections are difficult, we're going to have Kathryn talk a bit about how you can deal with these difficulties.
All right, great. So thanks, Ken. We'll get to some of my tips now. So we'll be starting by talking about the CARS section in particular. I wanted to give some tips of how to guide your studying to get a really high score in this section. So the first tip that I have for all of you who are either starting your studies or thinking about studying for the MCAT at some point is to start thinking about CARS from the beginning of that. Consistency is really important for building up these CARS skills. So it's not something that you can just do like a crash course in CARS the weekend before your exam and suddenly come out with a great score. Typically, I recommend for the students I'm tutoring that they even do a practice passage each day, or for some students who want a really high score increase, even 2 passages a day. So it should be a part of your study plan to say the very least. And depending on where you're starting and where you want to end up, you'll have to incorporate even more than just like 1 passage a day, for example. Okay, so the next thing I want to talk about is why this matters, why we need to be doing CARS practice, and how we should be improving from it. So a lot of these improvements that we tend to see from the CARS practice comes from not from doing a bunch of questions, but actually carefully reviewing the questions. So I'll talk a little bit about review next, but review is something that's so important that if we just do passages and don't look at what went wrong, we're probably not going to be doing a whole lot of learning as to what strategies that we need to use to get a better score next time. And then finally, you need to incorporate some sort of section length practice. As Ken mentioned earlier, this is a very time crunch situation when you're doing these 9 passages in such a short amount of time. So doing this section length practice will get you used to that timing. So on test day, you feel very confident that you'll be able to complete the section in time. So setting off a day in the weekend, for example, where you do a full length CARS section is a great way to start working on this. I usually recommend students use the AMC CARS. Usually closer to the test date, I encourage students to use this resource because the AMC does have the logic that is the closest to the actual MCAT exam since they're the makers of the exam. So that's about it for these general tips on how to get a top CARS score. Now we'll talk about how to review CARS. So I mentioned that this is a pretty big piece of what you should be thinking about doing after you complete a CARS passage. So if you just spent, say, 10 minutes doing a CARS passage, you don't want to just throw it aside. You want to create a system to keep track of all of the review that you're about to do. So I encourage students to create some sort of document to track their progress with the CARS section and input any review notes from their practice. What this means is that students should be reviewing every question that they've done for CARS, even the questions you got right. So for questions that you got right, you can go into your spreadsheet or Google Doc or whatever you're using to keep track and write out, for this question, I did a great job. It went well because XYZ. You want to reinforce the good behaviors that you're doing that are helping you get a good score. And then for questions that you got wrong, you want to take a hard look and say, what could I be doing better? And you want to be as concrete as possible with these takeaways, as I call them. So what you take away from your review should be something very specific, not just read better, but you could, instead of put read better, maybe put read faster, don't spend so much time on the first paragraph. That's more concrete and actionable than just telling yourself to generally read better. So another tip I have for you is to be very specific about what you're saying for your review notes. And you want to review this document quite often. So it's of no use to you if you create all these great notes and then just never refer back to them. So set aside a day or two every month to just review your CARS practice. This will lead to reinforcing those good habits, getting rid of those bad habits, and then hopefully pushing you up into the top percentiles of CARS. So those are the tips for how to review CARS that I have.
Yes, and I completely agree with all the points Kathryn just made. And just to really echo something she just said, which is when you do your review, having a specific point is really important. And another thing with a specific point, really try to avoid making it too focused on the content of the passage, right? A lot of times students just say, oh, I missed this question because there was this idea in the passage that I missed. But the problem is, if that's your takeaway, that's not going to help you with any subsequent passages because you're never going to see that same idea again. So instead, when you're trying to figure out why you got to answer wrong, you don't want to say, oh, I got this wrong because I missed this idea about so-and-so topic. Instead, you want to give yourself a takeaway that you can apply to other passages. For example, if there's a question that's asking, which of the following, if true, would most weaken the author's assertion about X? In these cases, if your explanation was, oh, the author made argument A, and I didn't recognize that this answer choice went against the author's argument. Well, if you're focusing on the content of the arguments, that's not going to help you. Instead, something more helpful would be something along the lines of, if I'm looking for something weaken, it has to directly contradict the author's assertion, right? It has to be the exact opposite direction. It can't just simply be something tangential, sort of, going in the wrong direction. It has to be the exact opposite direction. Okay.
All right, and I will now talk about the Chem Phys section and how to get a top score in this section. So some of the tips that I have will be about just how to set up your study plan. And the first one that I have for you is to not let material, what I call, slip through the cracks, meaning if you review something in your book and then you never revisit that topic again, that's what I would call having it slip through the cracks. You have no way of collecting that information for later review. So it depends on the student. I mean, some students love writing handwritten notes, other students like to put things in a spreadsheet. But the basis of this tip is to come up with a system personalized to you, where you can collect all of the things that you haven't yet mastered and review those topics often. So the weaknesses that you had before can become your strengths. So find a system, implement it, and most importantly, make sure that it's something that works for your specific needs. So a lot of students are liking to write things out on whiteboards, for example, a very tactile approach. Other students enjoy typing. So find something that pleases you, and then you will refer back to that strategy often. Okay, so the next thing I have for you is how to build this mastery that I'm talking about. So mastery of a topic, the way I like to define it is, if you could teach this to another person, you've probably mastered the topic. So the best way to build these masteries is to use active study methods. So active study methods could be like saying things out loud, writing them out, anything that's not just like reading it off a slide or looking at a flashcard that you've looked at 50 times already. So these types of things will help you to test your recall regularly, and you'll be able to work with the material and develop that mastery that you could use to then teach it to someone else. All right, so the next tip I have for you is about practice for the Chem Phys section. So this section, while there is a lot of content like Ken mentioned, there's also a strategic part of reading these difficult passages and trying to distill out the important information. So you want to start your practice as early as possible, and you want to incorporate practice at some point into your study plan. Now, there aren't that many great resources out there for practice questions, and you definitely want to save the A and C questions for closer to your test date. Those are the ones that are made by the test makers of the exam. So we typically recommend that students take those last because they're going to be most representative. So for this type of practice that you're maybe doing while you're reading your books, for example, just to build up that mastery, I would recommend more of like a third-party question bank, and there are a few of those that you could use. All right, so my next tip is about having a unique study plan. So if you go on Reddit and look up what a 528 student did to study for the MCAT, that's not necessarily going to be the best study plan to get you there, because we're all unique and have our own ways of learning. So this means actually thinking critically about what worked well for you in your classes in undergrad, or what things didn't work for you when studying in undergrad. And also think about the time it takes you to read books. So there's a lot to be considered, and just following like a cookie cutter study plan really isn't for everyone. So I encourage you to sit down and think about what's realistic for you, while still accomplishing things like reading a set of MCAT books and doing the AMC practice questions. All right, and then my last tip is to focus on reviewing your practice questions by recording concrete takeaways, kind of just like the way we did with CARS. So you want to have concrete takeaways that say, this is what went wrong here, but this is what I could do better next time. So to give an example, say you were doing a biochemistry passage and you completely missed something in the passage about an enzyme's properties. That would be a good takeaway to put down and say, when asked a question about an enzyme, skim the passage and see if that content is mentioned at all. That's something really concrete that you can take to the next question and say, oh, I see that something's mentioned here. I should scan the passage and look to see if the passage has any more information for me. So these are my tips for the Chem Phys section. There are a lot of them here, but if you can really customize your study plan to you and work in a lot of practice and mastery of the topics, you're on a good footing to getting a high score in this section.
All right, great. Thanks for all those tips. The next thing we're actually going to do is something that is will probably be more entertaining and interactive for all of you. We know that often we talk about all these tips and strategies, but we never really demonstrate how they work. So what we have here is a sample Chem Phys practice passage, so very much MCAT style. And what we're going to do is we're going to go ahead and walk through this passage, and you're going to be able to see, for example, how Kathryn, as a 99th percentile MCAT score, reads this passage and what she sort of takes away as the key points. And then we'll go ahead and walk through the different questions and point out various strategies and techniques that you can think about. So we have this practice passage right here, and when you're taking the exam, you do have a highlighting tool. And of course, since we're using a presentation, we don't have something perfect, but I will set up a highlighter tool so that way I can be highlighting here. So Kathryn, do you want to go ahead and walk us through this passage and sort of let everyone know what you're thinking as you're reading through this passage and maybe what you might highlight?
Okay, great. So we're taking a look at this passage, so we'll get started. So reading the first intro here, chlorite dismutase is a homotetrameric enzyme that catalyzes the decomposition of chlorite into dioxygen and chloride. And we're given reaction 1 here. So since this is an intro sentence, it gives us a lot of information, particularly the name of an enzyme, chlorite dismutase, and we can see the reaction that it catalyzes down here. Okay. So as far as things that I might want to highlight is the name of the enzyme, chlorite dismutase, just so I know where I can find important information about it. So I wouldn't necessarily highlight that it's homotetrameric and all that information, because if I want info on chlorite, it'll be right here. Next, I would probably just look at this reaction and make sure that I understood what's going on. So I can see that we have the decomposition of chlorite, and then we have 2 ions, or actually 1 ion and O2 gas forming. So to me, I wouldn't spend too much time analyzing this yet because we're not asked a question about it. So I would just feel comfortable knowing that I could interpret it if I needed to later, and then keep reading the passage. All right, so reading through the next part of this passage, it's talking about to produce chlorite dismutase for stoichiometric and kinetic analysis. This enzyme was expressed in E. coli cells, and it's talking about using isoelectric focusing. Pure CLD was found to have an isoelectric point greater than 9.6, which is significantly higher than most soluble E. coli proteins. All right, I think this is a good stopping point to kind of talk about what I'm seeing here. So we're doing a stoichiometric and kinetic analysis, and we're expressing this in E. coli cells. So this gives me an indication that we might be starting some sort of experiment here, and E. coli cells are probably going to be our experimental expression organism here. So looking at this, I notice isoelectric point greater than 9.6. This is something I would definitely highlight because I know that a lot of questions would ask about maybe a specific pH, and I might have to refer back to this isoelectric point of the enzyme to answer that question. So far we're really focusing on things that I want to kind of bookmark for later when I'm going to the questions. Okay, and the other thing that is pretty important here is that it's significantly higher than most soluble E. coli proteins. So I would probably try to capture that in some way, maybe significantly higher than E. coli proteins. That would be good enough for me to refer back to. Okay, so I would continue on after this point. So after lysing the E. coli cells with sonication, the cell lysate was passed through an ion exchange column at pH 8.6, and the flow through is found to be 70% of our enzyme by SDS page analysis. Okay, so for this, I know that as a person who has been studying for the MCAT for quite a while now, that they're going to prompt me to recall some of my content knowledge. So here, we see a lot of things that we should know from our content base, such as ion exchange column. So that's one of those methods that we could use to purify something, like a chromatography assay. And then we can see SDS page analysis as well. So I would start thinking about, okay, how could they use those? How could I use my content knowledge to answer questions about these? So I wouldn't highlight anything here, but I would remember that important information about the experiment is likely found here. Okay, and then I would continue on. So reading through, it's talking about a steady state enzyme kinetics analysis. And pause here, kinetics analysis. So I'm starting to think of my kinetics content knowledge. And to read on, it says that different quantities of chlorite was dissolved in potassium phosphate buffered saline, and then it gives us the concentration and the pH to form solutions with concentrations over 800 to 1500 micromolar. Okay. For this, I would not really highlight much here, just to know that I could come back here if I needed to know specific data about the buffers. But I would move on from this and just keep in mind that I'm looking for anything that might test my kinetics knowledge. Okay, so it says that a catalytic amount of our protein was added, and it gives us the concentration. And then it says the initial rate of chlorite depletion was measured, figure 1. All right, so I would probably go over to figure 1, probably figure 2 here. So just taking a look at this graph, and I'm like, okay, this is our typical Michaelis-Menten curve. So again, bringing in some of the content that I had to know from my books and trying to just take a look and make sure that nothing looks off. And I wouldn't interpret this right away because I want to read through as quickly as possible, but I would make sure that I felt confident that I could get the kinetic data from this graph. And I feel pretty comfortable with that, seeing as we have the initial velocity and the concentration of substrate right there, which are normal axes for this kind of graph. Okay, and then we left off at where it mentioned figure 1. So just getting to the bottom of this passage here, looking, it says to determine if the products of chlorite decomposition inhibits the reaction, the researchers measured the activity of the enzyme with varying concentrations of the presence of oxygen did not have any effects, but the Kcat and Km of the protein decreased with increasing concentrations of chloride. Okay, so that last sentence does have a lot of information in it related to our content knowledge of enzyme kinetics. So looking at KCAT and KM, those are things that we should remember from our Michaelis-Menten kinetics. And we know that using KCAT, we can calculate things like our enzyme or we'll just cut that part out.
The Vmax, right?
Yeah, Vmax, thank you. The presence of O2 did not have any effects, but the KCAT and KM of CLD decreased with increasing concentrations of chloride. Okay, so based on this, I would know that they're testing our content knowledge of kinetics. So I would be looking and seeing, okay, we have our Km, our Michaelis constant, and then we have KCAT, which we can use to calculate other kinetic parameters if needed. So this would pretty much wrap up my look at this passage. I usually try to keep it pretty brief until I see the questions. That way I'm not spending too much time reading and I have more time to critically think when the time comes.
Yeah. And just to emphasize some of the points there that Kathryn made, because again, what we want to leave you with today are some of these important strategies. So you can see that the highlighting is very specific, right? She's not just highlighting everything because, too much highlighting is the same thing as no highlighting. Another important strategy that Kathryn employed was that as she read through this passage, and anytime there's a reaction or a figure, anything other than text, you can see that she spends very little time on these pieces of information. And that's simply because she knows that she can wait till she gets a question on one of these reactions or figures before taking a look at them. And that's because sometimes on the MCAT, you'll have passages with 3 or 4 figures. If you have 3 or 4 figures, it's very likely that you're not going to get a question on every single figure. So in that case, it's actually not a good use of your time to thoroughly review each. And your points comes from the questions, not from reading the passage alone. So the goal is to get through the passage, identify the key information by highlighting, and then getting to the questions as soon as you can. Some other things that you'll see that Kathryn did as a really high level student is that when she was reading the passage, you can tell that she's done so much practice at this point that she's able to predict, oh, when I see these are terms I should know from MCAT, like ion exchange column, KCAT and KM. There's a good chance the MCAT is going to ask me about this information. And that's really helpful to know when you're reading a practice passage. If you can already predict what parts of the passage the MCAT's going to ask you about, then that will help you a lot. Okay, so now what we want to do is take a look at some questions. So our first question is, in reaction 1, how does the oxidation number of chlorine change? All right, so for this question, this is going to be a general chemistry question, right? So we're looking at oxidation number and we're looking at reaction 1. Since it's asking about reaction 1, we definitely need to go back to the passage. So if we take a look at reaction 1 over here, they were asking about chlorine. Kathryn, do you remember how to determine the oxidation numbers?
Oh, yes. So we would want to take a look at whichever one would have higher priority. In this case, it's oxygen, which would have a 2- charge per, or 2- oxidation number per each oxygen.
Mm-hmm. And therefore, what would chlorine be?
So we have to be careful with this one because the molecule has an overall negative charge. It won't be completely balanced. So we have to balance it so that there's one more negative number for the oxidation state. So it should be +3 for the chlorine here.
Mm-hmm. That's correct. And something I just want to emphasize here is that you can see here we were careful and wrote, 2 minus, 2 minus, and +3. I know a lot of students can sometimes get a little lazy. Instead of writing 2 minus, 2 minus, to just write 4 minus. And I'm 100% confident all of you know 2 minus plus 2 minus gives you 4 minus. But the potential risk of writing 4 minus is if they ask you what is the oxidation number of oxygen, you might accidentally select the answer choice that is 4 minus. So for oxidation numbers, definitely write them out separately. So then if we're looking at chlorine in our product, what is our oxidation number now?
So that would be the charge of the overall ion here because it's a monatomic ion, so it would just be -1.
Mm-hmm. Perfect. So this one is just content knowledge applied directly to the passage. So in this case, we can see that our oxidation number for chlorine went from +3 to -1. So we're looking for an answer choice that matches that. And of course, that perfectly matches answer choice D. So that has to be our correct answer. Okay, let's take a look at our next question. Number 2, which of the following amino acids most likely contributes to the stabilization of chlorite in the active site of chloride dismutase? All right, so this one, again, we need passage information, but there's some strategy I want to leave you with here because this is an extremely common question you see on the exam. And there's 2 approaches to answer this question depending on the information that you're provided in the passage. The first approach is if they give you information in the text, right? So sometimes the passage will say the active site required aromatic amino acids for stabilizing the ligand, or sometimes it says that substrate binding requires several key basic amino acid residues, right? If there's passage text, go with the passage text. That tells you which amino acids are important. Sometimes in the passages, they won't give you that information in the text. If they don't give you that information in the text, that means you have to use the structure of the molecules given to you in the passage, right? And of course, there's another case where you get both. You get text information and structure information. This is where it gets a little tricky, right? You're thinking, which one do I go with? Do I go with the text in the passage, or do I go with the structure of the molecules? The answer is the text of the passage trumps structure of molecules. So if there's the answer in the passage, you always go with the passage text. And it's only in the case where the passage text doesn't give you any information about this, then you go with the structures of the molecule. And of course, Kathryn, having read through the passage, do we have any text telling us what amino acids are important for stabilizing our enzyme chloride dismutase?
So I do not remember any information about the stabilization. So I think we would have to defer to the structure on this one.
That's correct. So if you're looking at the structure of the substrate, what do you notice about the substrate?
I noticed that overall charge of the molecule is negative. So it'll probably be some sort of electrostatic interaction that leads to this binding here.
That's correct. So if our substrate is negative, then you would expect what type of amino acid it would be able to stabilize that?
So we would want an amino acid that has an attractive charge for this negative molecule. So it should be positively charged. And if you remember from your content knowledge, the positively charged amino acids are the basic ones. So we would look for a basic amino acid.
Perfect. And which of these is our basic amino acid?
So this one would be arginine, our basic amino acid, so C.
That's correct. And of course, if you're looking at the other choices, phenylalanine and valine, both nonpolar, and D, glutamate or glutamic acid, acidic. Excellent. So moving on to question 3, which of the following correctly describes the chromatography used to purify chloride dismutase? All right, so Kathryn, I think you noticed this when you're reading through the passage that they were talking about this technique. So do you want to walk us through this one?
Yeah, sure. So I would want to go back to the passage here and just take a look at what they mentioned for our column here. So I'm orienting myself to the passage, and they talked about this column at the last part of paragraph 2. So we'll kind of zoom in on that area. And it says particularly that the cell lysate was passed through an ion exchange column at pH 8.6, and the flow through was found to be 70% CLD by SDS page. Okay, so we're finding that our enzyme here is in the flow through, which means that it didn't bind to the column. So we're looking for an ion exchange column that would not bind our CLD enzyme. And furthermore, we should note that it's at a pH of 8.6. So if we compare that to the isoelectric point of our enzyme, It is 9.6. So right now, this is still going to be protonated rather than deprotonated like most of those other E. coli proteins. So it should have a positive charge, and the E. coli proteins would either have like a negative charge or maybe a neutral charge, depending. Okay, so if we take a look at this, I think we're good to go back to the question now and start doing some thinking about it. All right, so if we're talking about the chromatography used to purify it, since we know it's in the flow through, we know that it's not binding to the column. So yeah, we can write some notes on this. Usually that helps for these critically thinking type problems to have a few notes down. Okay. Further, we know that CLD is an enzyme and it has a positive charge. So I noticed that some of these answer choices mention normal phase or reverse phase. So this has to do with what the phase of our solvent is, or our mobile phase. So because this is an enzyme, we want it to have a polar mobile phase if it's going to be in the flow through. So that's not the normal conditions. That's actually reverse phase. So usually we have a non-polar mobile phase. So I would immediately be able to rule out A and C based on the fact that our positively charged enzyme is going to be in the flow through. Then we're left with anion exchange and cation exchange chromatography. So we have to think through this one, and students often get confused about the names for these types of chromatographies because the name is actually what they bind. So anion exchange chromatography binds negatively charged particles, and then cation exchange chromatography actually binds positively charged particles. And since we know that our enzyme is positively charged and we do not want it to bind to our chromatography setup, we know that we want it to go through. Therefore, we want it to be with the anion exchange version because this positive charge is not going to be attracted to our stationary phase, so it will be in the flow through, just like the passage said. So this is an example of a critically thinking based type problem that involved a lot of content knowledge. So I would choose B as the answer here.
All right, so you can see some questions in MCAT slightly easier, some questions in MCAT more difficult. All right, so looking at number 4, what is the Km in micromolar for chloride dismutase? All right, so this is one of the standard questions where they either give you data to determine this or they give you the graph. And as we recall from this passage, we did have this Michaelis-Menten saturation curve. If we want to determine the Km, remember the Km is the substrate concentration at 1/2 Vmax. All right, so we're looking at the Vmax. You know, the Vmax would probably be close to this value over here. So if we're looking at 1/2 Vmax, it'd probably be around here. And then we're just looking at the substrate concentration at this point, which we can see is just slightly below 250, right? Just below 250 micromolar, right? Let's just say 200 micromolar. You can round numbers and be perfectly fine on the MCAT, right? Nothing has to be perfectly precise. So if we're looking for 200 micromolar, we can then take a look at our answer choices to see what fits. First of all, it's in micromolar, and they want it in scientific notation. So if we change this to scientific notation, it should be 2 times 10 to the 2 micromolar. So this actually makes it easy because if you just look at the exponent, you can see it's not going to be A, B, or C because they're too large. So it has to be D, which is quite close to the number that we thought it was going to be. Okay, and finally, we have number 5, which Lineweaver-Burke plot most accurately depicts the kinetic data of chloride dismutase with and without the addition of chloride. So first thing I want to emphasize, enzymes and biochemistry in general, super high yield topic for MCAT. You definitely want to know this. Now, the key information you need to recall specifically with Lineweaver-Burke plots is to know that the y-intercept is equal to 1 over Vmax, and the x-intercept is equal to negative 1 over Km. So we need passage information about chloride dismutase to answer this question. And if you recall in the last paragraph of the passage, they gave this information that KCAT and KM are both decreased with addition of chloride. All right, so KCAT and KM are both decreased. So we know that KCAT is decreased, KM is decreased with chloride. And KCAT, you should recall, is related to Vmax, right? So Vmax is equal to KCAT times the total enzyme concentration. So if your KCAT decreases, that means your Vmax decreases. So now we know what happens to Vmax and Km. So if we look at the intercepts, you have to be careful because it's the inverse. So if you decrease the Vmax, that means you're dividing by a smaller number. If you divide by a smaller number, that gives you a larger value. That means our y-intercept should move up when we add the chloride. So we can see that matches in A. If we look at B, well, this is C, it doesn't match because the y-intercept drops. Also doesn't match B because the y-intercept drops. If we look at D, we can see that the y-intercept increased. So we're looking between A and D. The second part is we know that the Km decreased. Same thing, you're dividing by a smaller number. Dividing by a smaller number gives you a larger number, but you have to notice the negative sign. So you have a larger negative number. So our x-intercept should shift to the left on our graph. And if you look at A, it does shift to the left. And if you look at D, it looks like it hasn't moved. So that means our answer is A. Okay. So that's how we would run through an MCAT practice passage for the Chem Phys section. So hopefully that gives you some of the ideas of the different strategies you can employ when going through Chem Phys practice passages. The next thing I want to talk about that's going to wrap up our webinar for today is how MCAT tutoring can help. So you notice all of these different challenges with the MCAT, Chem Phys, and the CARS sections. They're challenging, but MCAT tutoring can help you with these challenges. There's several reasons why MCAT tutoring is helpful. The first is complete personalization. You'll remember earlier that we talked about the importance of setting up a custom study schedule that's built around you and not something generic, right? Again, don't go on Reddit and follow some 528 score study plan. You want a study plan that's going to address your specific weaknesses so you can reach your target score. One-on-one MCAT tutoring will allow you to do that. Our tutors will create the study schedule specifically for you. Number two, next level proficiency, right? It's one thing to study the MCAT content by yourself and just read the books and watch videos to try to understand the concepts, but there's always going to be some of those topics, right? Some of those Chem Phys topics like mirrors and lenses or circuits or organic chemistry reactions that you never really understood in college. Rather than trying to struggle and figure out those topics on your own and maybe or maybe not succeed, you can simply have a tutor teach that concept to you so you can have a strong understanding of all the topics you need for the exam. Next, study plan design. We already talked about this. Not only will we design a schedule based around your specific weaknesses as well as your goals, we set up the structure for you. So that way you know what you're going to be doing for every day of your studies from the beginning of working with us all the way to test day. And some additional reasons of why you not only want to do one-on-one MCAT tutoring, but you want to work with us for MCAT tutoring is we have the best tutors in the industry, right? If you just go to our website, medschoolcoach.com, check out our MCAT program, you're going to see that our tutors are extremely qualified. They not only got fantastic MCAT scores, but they're also excellent teachers at heart. And MedSchool Coach is an excellent company to work with, because we're a company that's focused on every aspect of becoming a physician. If you look at many test prep companies, their goals are simply to help students take an exam. And if students do well, or don't do well, it doesn't really impact them. But for us, it does have a significant effect because our goal is not just to help students with exams. Our goal is to help them become physicians. So when a student preps with us for the MCAT, our goal is to get them a good MCAT score. So they're going to want to continue to work with us to apply to medical school, and possibly in medical school have us help them with the board exams as medical students, right? So we have this level of accountability where if a student does poorly with us, we are highly incentivized to want to help that student do better again, so they will continue working with us so we can help get all of these students to medical school and eventually become physicians. Last thing, of course, is the personal touch. We're a small test prep companies. We're not one of those companies that you hear about all the time, and that can be a huge strength simply because if you want help, we can get it done very quickly. And if there's any issues, we can also resolve them quickly. So some ways that Med School Coach MCAT tutoring can help. And just to emphasize a few more points, our goal is not to make students, sit through a bunch of lessons that isn't going to be helpful for them. One-on-one tutoring, we focus on what you need help with. We'll also help you with whatever you need. So it's not just a matter of teaching you science content. So if you think about the practice passage we just walked through, we went through a lot of different strategies and techniques. That is just a little tiny bit of the strategies and techniques that we teach our students. Through one-on-one tutoring, we teach a whole bunch of strategies, not just for the Chem Phys section, but for all 4 sections of the exam. And of course, our success is really quite amazing. Our average score improvement is 10 points. And I actually think with the most recent test dates from students who just took the MCAT and got their results, it's actually, I think, rounding up to 11-point average score improvement. So that's fantastic. Okay, so that is it for our webinar for today. So I hope all of you enjoyed all of the information that we passed along to all of you. If you're looking for additional sources of great information, make sure to check out our YouTube page where we have a lot of great MCAT videos going over different mnemonics to help you memorize various topics, or additional videos going through the different aspects of applying to medical school. Alternatively, if you'd like to listen to podcasts, make sure to check out our MCAT podcasts. We have one of our excellent team members that releases a podcast every week on different high-yield MCAT science topics. So it's a really great way to study passively for the MCAT. And with that, we're going to go ahead and call it a night. But if you have any questions that we weren't able to answer for you this evening, please email us at info@medschoolcoach.com, and we will help you out with whatever you need. And with that, have a good night, everyone.
Bye, take care, everyone.